Thank you, Christian. So welcome everyone to this talk on DDD and REST, domain-driven APIs for the web. My name is Oliver Gierke. I work for a company called Pivotal. Has anyone heard of Pivotal before? A couple of hands, like guys behind the Spring framework, basically. I'm leading the Spring Data projects. There will be a second talk on that topic later this afternoon. But this talk actually is also built on some of the stuff I've been facing while developing Spring Data projects. So just to give you a rough idea where we actually come from is that in Spring Data we have like a couple of modules that speak to relational, non-relational databases, and the top level API basically is a repository model. So like the DDD concept of repositories. So that's why, I mean, I've been doing this stuff since 2008. So I've been exposed to the concepts of repositories, aggregates, and stuff like that for for quite a bit of time. And then we had these customer projects where we build RESTful APIs, and I found myself repeating a lot of code in terms of using hypermedia features in those REST APIs. So we started to basically decustomerize that code and turn that into a library called Springhadios, put that on GitHub, and it became pretty popular. And then we basically thought, okay, I mean, the repositories are sort of implementing, I mean, that's the concept of a repository, a collection of aggregates, right? And there's like these, we've seen people implementing the same patterns on top of these repositories for quite a lot of time. So usually doing collection resources like /customers for all customers and /customer/ID for like a single customer. All these patterns you can find. There's even like in the RESTful patterns book from O'Reilly, there's one that basically discusses REST implementation scenarios from this patterns point of view. So we thought, okay, what can we do like implementing those patterns on top of these APIs and make basically your life easier in terms of like removing the boilerplate code from exposing a domain model to as web resources, as REST resources, basically. And that's what Spring Data REST actually, or when that project was coined. But the fundamental idea was, or while developing that project, I'm not going to talk about data REST, not at all would be the wrong statement, but only very little. The fundamental point that I found was that, okay, while implementing that module, there were certain concepts that pretty much, or that we realized, okay, we're doing something like on top of the domain model that's more conceptually than implementation specific. So there are certain concepts that translate nicely from the domain-driven design world into the REST world. And so that's basically what this talk is going to be about, right? So when we're doing domain-driven design, I'm sort of assuming you're familiar with the very, very fundamentals. I'm not going in too much detail, especially as we have 50 minutes only. What concepts are there in domain-driven design that are quite essential if you want to build good REST APIs, right? So implementation-wise, that's basically the question, right? Assuming you have a decent DDD model, what do you have to do to actually build a good RESTful API on top of that? Which you can also phrase the other way around, which traits of a DDD model are very important so that you can actually build those good REST APIs, right? All right, so let's get the elephant out of the room. Who's read the book till the very end? Okay, a couple of hands going down. I've recently met someone who's like saying this is the greatest and this at the same time most boring book of software engineering. And there's some truth to that because Eric's very verbose and very storytelling-ish basically in the book, so it's very thick. And the thing is that there are a couple of real nuggets in there, or real gems in there, that are at the very end of the book, like things like bounded context and stuff like that come very late. So people sometimes miss those and just go, okay, I know what an entity is, right? JPA has an entity, so that's probably it. But that's unfortunately not it. There's a like more condensed version of the thing. What's so funny about that? I mean, that's the spring boot of the other thing, right? That's a good analogy, actually. Anyway, if you want to get a quick overview about the core concepts, the important concepts, start with this thing. It's like 100 pages PDF, downloadable at InfoQ. And if you've done that, then definitely get the book. It's worth reading it, but it's also kind of a bit of it's more challenging. Let's phrase it this way. All right. So what the book is about, like a couple of different things. So the first thing is it's so-called the ubiquitous language. So basically the idea of taking the domain language and sort of finding ways to turn that into code. So basically connect the business with the code. There is this fundamental concept of bounded context. So basically acknowledging that there's not a single view of a customer or an order in your system, and that you basically have to find these bounded contexts to have like more specific views on those concepts. And once you have those, there's like the context mapping stuff. So basically how these bound contexts interact with each other. Again, even more advanced stuff, and that's actually quite in the front of the book. This is the fundamental concepts that basically everyone talking about DDD is sort of exposed to, and we're going to briefly look at those 4 up there, because in the context of building RESTful APIs, these concepts share a couple, not share, but expose a couple of important traits that are very helpful if you want to build good RESTful APIs. Or the other way around, if you ignore those, you probably have a hard time in like building something decent. All right, so let's start with. I mean, that's something I want to focus on a little bit as well, because the question usually comes up that, okay, even if we acknowledge all these concepts like value objects and entities, we'll go through those in a bit. How do we actually implement those, and why don't we introduce a value object for something, right? What's the reason for that? And that's usually like driven by hurdles that you get with technology and stuff. But we'll get to that in a second. So first thing, value objects. So you've probably seen code like this. I call this stringly typed code because everything is a string, right? I've recently heard that object-oriented code is actually making every property an object and casting it to what you want and when you use it. But kidding aside, what's the problem with code like that? No idea? If you have a method like this, it's like really easy to actually mess up the parameter order, right? That's pretty obvious here. Also, how can this code in here be sure that this thing here that's supposed to be an email address actually is an email address? Right? There's like some technologies that propose to put an @email annotation on this thing, but fundamentally that code still can't be sure, right? It's still a string. And from the business point of view, that's where the connection to the ubiquitous language comes into play, is that an email address is an email address is an email address. It's not an arbitrary string, right? So what DDD is suggesting is to basically introduce value objects for those things so that you can actually equip the types with the constraints that your business imposes to that concept, right? So there's probably rules what a last name could actually be in your system. There's pretty obvious rules. I mean, there's like that one-page regex expression to check for valid email addresses. But if you turn this thing into an actual type, right, you can use the type system because, I don't have that, I should add that slide here. That method signature that we just saw will change to an email address, get an email address parameter, right? And assuming that email address, the type is correct, implemented correctly, that code can be sure that if it gets an instance, if it ever gets called, that thing will be a valid email address, because you can like write unit tests for that thing. You could like reject invalid string values in the constructor, so you can write more safe code in the first place. All those details aside, the thing that I'm trying to get to here is that DDD is all about making things that are usually implicit in your code or in that stringly type code explicit, right? So explicitness is a very key thing here, because that actually helps write better code, as I probably just like got across. The thing is that implementing those types is a pretty, what does PETA actually stand for? I don't know. Don't ruin the joke, sorry. Anyway, and some languages equals to Java usually, right? The thing is, for value objects, you need to create like a constructor taking that thing. You have to have final fields. You have to implement equals and hash code correctly. You also have to keep that correctly in case you change that type ever again. So there's a couple of things that are in Scala, for example, as case classes. There's a couple of things that make this a bit hard or look hard for some developers, which is one of the reasons they usually go, let's keep this a string and put an email address annotation onto it. But yeah. There's a really great talk by a guy called Dunberg Jonsson. There's this, it's a call, like power use of value objects. It's, I think, a 60-minute talk or something on InfoQ. I think I've watched this like for a dozen of times at least, and I still find something useful in it. It doesn't mean I didn't pay attention in the first place, but it's a really good one. He basically takes a giant piece of code about that deals with rate exchanges, or currency exchanges. That's currency exchange rate. Sorry. And introduces value objects to make what's actually going on in that code more explicit, and he ends up with something like 15, 20 line-ish that really, or you could sort of read it, not really like prose, but it's way more understandable in the end. Good talk, definitely look at it. So to make this easier in the implementation side of things, Lombok's a pretty cool thing. Has anyone heard of Lombok before? A couple of guys. So what you basically can do is you just like put this add value annotation on your code, and it's an APT processor for your Java compiler that then will generate all that stuff that you basically need here. Like see the equals and hash code methods. Those things become final fields, private final fields. That's pretty it. It's just like taking the pain out of creating that class. And I mean, creating is one thing, right? I could just do the generate getters and setters thing, which Kevin Henney once said, code generation so that you can do the wrong thing faster. So that's basically taking the pain out of writing the code, and also you don't have to read all of that stuff that's sort of implicit. Anyway, I've been pinged on Twitter, and somebody was snarky with me because I didn't mention auto value. Similar thing to value to Lombok basically, but it's using interfaces and code generation. Did I say something against code generation? Just an alternative to be sure. Okay, so that's value objects. The key thing is don't be afraid to, I mean, or try. You have to make your way around those problems you get with them, like all the coding effort. But making those concepts explicit leads to better code, and we will see how we will actually achieve that in REST APIs later on. So entities and repositories. Let's look at some totally arbitrary, I mean not so arbitrary, of course, model of a domain. E-commerce, pretty easy. We have a customer with some payment information, addresses, whatnot, invoices. We have orders that are placed by a customer. Those orders have line items, and those line items point to products. So the thing is that in that model, and that's actually, it already becomes a slightly obvious. I've actually grouped those bullets here, or those ellipses, slightly to actually express that the relationships between those things have very different characteristics, right? So the order and the line item, that relationship is a completely different one than the one from the order to the customer. Why is that? Eric and DDD speaks of so-called aggregates. That's like a concept of like grouping entities. And the very important, or the most important thing about those things is that those aggregates have a so-called aggregate root, which in this case would be like product, order, or customer. And that rule sort of is that once you the purpose of those aggregates is to enforce business constraints, right? So let's say you have a certain minimum amount of like value that you have to like. What's the English word for Mindestbestellwert? Where the Germans? Minimum total order amount, whatever. So you have to assume you'd be able to just manipulate or add new line items to the entire system on their own basically. Then you'd never be able to control that Mindestbestellwert. You've learned a new German word. For the entire order, right? So the idea is that like the order becomes an aggregate with the ordered thing, the aggregate root, so that whenever you want to add or remove a line item, you have to load the order, manipulate the state of the order, and then write that basically back, right? So that's that's one key thing, and the other key thing is that the aggregate only refers to other aggregates. So the order would never refer to an address directly, but only to the customer. I mean, that could slightly change, of course, because you probably have something like an address here as well. But then again, we're discussing bounded context. What's an address in the context of an order, or in terms of like the customer details, the CRM system, basically. So it's different things here. All right. So the question is, how can we actually differentiate between the two? Because if you think of things like JPA, in JPA, everything that has or that's mapped to a table is basically an entity, which is unfortunate because that's by definition not the definition that entity has in DDD. So the general rule of thumb for the Java context here is sort of you'd create repositories only for the entities that are actually aggregate roots. Which is kind of a neat thing, because if you like aware of that rule, you can actually look at your system and say, okay, I have my e-commerce system and I have a repository, an order repository, right? So whenever there's a repository for something, that something is going to be an aggregate root. On the other hand, we're never going to have a repository for line items because they're just like transparently managed by the order thing, right? So it's not that you can just like arbitrarily add the repository to an entity and then turn them into your aggregate and then everything will just like fall into place. It's just that if you add the repository, you end up with an aggregate and you have to be aware of that. I already mentioned that aggregates are scope of consistency. So like the consistency of the entire order is governed by the aggregate root. And I can only do manipulations to that thing through the aggregate. Yeah, so that's basically what I explained right now, right? Yeah, that's it. Sorry, I got ahead of myself. Anyway, the other important thing is, again, we need the aggregates are the thing that we refer to. So like from an aggregate or from like something nested in an aggregate, we only refer to other aggregates. That's kind of handy and will come in handy when we talk about like REST and links between resources and stuff like that. All right, so there's a final thought I have on this thing here, which is that one. What do I mean with that? There's been some time when a couple of tools were very popular that suggested, well, there's your database, and then you basically just like let this tool run, and it will extract all entities from it, and then we will basically create like a CRUD application on top of that. Has anyone ever seen that stuff working? Like, I mean, really working? Yeah, really, in terms of really working. Management, really, okay. So the thing here is that, let's get back to the difference in relationships, right? In the order has line items, the order belongs to a customer. In the database, those two representations are basically represented with the same means, like a foreign key constraint, right? The line item has a foreign key pointing to the order it belongs to, and the order probably has a foreign key to the customer who placed the order. So there's no way on the database level, on the pure table level, to distinguish between the two relationships. But they are, as I just pointed out, like in terms of where are the aggregates, where are the aggregate roots, it's crucial to actually distinguish between the two. So I'm not even saying that like the kind of code generation or deriving your model from the database is a bad thing per se. You just can't stop when you've done that, because you have to look at all the entities that you've created and have to basically needs to identify the aggregate roots, right? Why is that? Because usually JPA just allows you to have object references from one class to another, right? You could hold a customer instance inside the order pointing to it. However, it might even be the case that you not even want that, because that might cause the order to load the customer, and by that to load the address only if you want to just to, let's say in the context of like iterating over the line items. So these tools are, I mean, they usually result in like I load a single thing from the database, and then by the virtue of the code that was generated, I pulled in all the other, basically the entire other database into memory. So the question really is, like already on the database side of things, where do we want to cut off things and maybe only refer to a customer ID, right? Instead of being able to traverse the customer. That's where basically where already or again the topics of bounded contexts come in. So if you like, let's say, really separate the CRM part of the system from the order part of the system, then you usually go ahead and it's basically just not allowed to refer to other types from another bounded context here. I mean, that doesn't even mean physically separating in terms of like this has got to be a microservice because they're so invoked these days, but that could just be like a separate package in your monolithic application. Question over there.
The customer has an address.
Yeah.
And I will see the customer as a kind of master data, and the address as the customer's master data.
Mm-hmm.
And then when you make an order,
mm-hmm.
you could, so to speak, copy the address to the order.
Mm-hmm.
Because that was the address of that order, and maybe you want to alter that because it might not be the customer's real order, but it's kind of delivery location.
Mm-hmm.
What's your thought on copying master data?
So the question is, okay, what just for the recording, the address of a customer probably has to move to the order because like when the order is placed, there has to be a shipping address or a billing address or something. That's usually exactly what happens. So the data gets physically copied because you want to separate like the life cycle of these things, right? The life cycle, the shipping order, the shipping address that you put into the order must not change even if the customer like removes that address or something, right? Because you have to know you ship that address to that thing. So that's like I probably should remove address from here because it usually creates discussions. I was kind of more the core point here really is that there are different relationships between different elements of the model. Okay. All right, so bounded context, I mentioned those. This is a very entity-centric view on the system. However, you usually go ahead and like if you're doing DDD intensively, you like have your system split up into different bounded contexts, and then you realize that things like the customer is represented in different parts of the system. Actually, the order is a quite a like the concept of an order is quite a good example to describe why this is reasonable. Let's say you have this order with a couple of line items. The accounting bounded context or the accounting subsystem doesn't really care about like all the line items. It basically it cares about the total amount that has to be paid and the payment information of the customer, right? The shipping subsystem, however, sort of is interested in the line items, in the individual line items, because it has to know about like the packaging size that's required, the packaging fees and whatnot. That might even interact with each other. But the fundamental thing being here that you usually have one of these bounded contexts who's giving identity to something, which is like the user registration when you enter, like when you're the customer or you want to register with that system, you usually start with some very fundamental information and then you add on other information that, if you look closely and like browse Amazon these days, whenever there's like, I mean, usually there's not even a single screen where you can edit all your information, but you have different screens for, let's say, your payment information, for your shipping addresses, whatnot. And if you look closely and watch the URIs, you can even see that to edit that information, you're routed to different systems. So you're not even editing these informations or this information in a single e-commerce system, but in different systems even. All right. Okay, so domain events, again, I want to reiterate on the explicitness thing. So you could start like when you're just like writing your domain model, you could go ahead and just like poke getters and setters everywhere, right? So when you move, let's say you want to change your customer address, your customer's address, you could just like call set new address and go ahead. Like you basically treat your objects as data, all right? You just take data out of the database, change it, write it back. The first thing that like not really Eric, but a guy called Von Vernon, and who's written the book Implementing Domain-Driven Design, is recommends is to turn those things into explicit operations. So there's this quote in the book where he says that if you're calling two setters in a row, you're basically missing a business concept, right? So that should be really one method, let's say taking two parameters or something. So I don't want to go like too deep onto that, because that's of course like an exaggeration here. But the thing is that like it's usually better in code to have like explicit operations on your entities, on your aggregates, especially. Say I move this aggregate from state A to state B, right? And by that I mean that's just a state transition literally. Okay, explicit operations. So the question is what you actually do in those state transitions. You could go ahead and just like in that method basically record the changes that you have in business events. So it might be just interesting to realize, okay, if we change the address of a customer, that's sort of a customer moved event, right? So you could go ahead, keep those events in the aggregate, and then have like some code that basically pulls those events out and stores them separately in the database. So you basically stay with your persistence model and then separately persist events, even maybe to the same database or to a different one. But the interesting thing here could be is that these domain events are like representing the state transitions, right? So you can just to get back to the REST topic slightly, and we will see more of that in a second here. What you can do, and that's basically like turning into or slightly diverging into a like system of systems discussion really. What I've seen systems doing successfully is to actually expose HTTP resources for those events, and then expose an atom feed or something, and by that sort of let systems communicate with each other, right? So you place an order, you have a new event added to the atom feed that says, okay, it was an order placed ordering these three like trousers and a TV and whatnot, and then the stock keeping system basically going ahead and then reading that feed and then updating the stocks of those things. So it doesn't. What I'm trying to get across here is that events doesn't necessarily mean messaging or have to mean messaging. Yeah. Anyway, some operations as events, and if you like basically wanna do the gold standard of this, then you're sort of getting into event sourcing, which basically means the current state of your system is not even like read like from the same database you write your events to, but it's basically derived from replaying all the events that you've recorded. So you fundamentally change the way you're architecting your system really. There's a framework, Axon, I think, if you're into CQRS and event sourcing, that supports those architectures quite well in the Java space. All right. So what does all of that got to do with REST? So the first thing I wanna get across, that although there are like some HTTP methods that easily or that nicely map to like CRUD operations, right? You post to something to create something, you put something to update that very something, and then you can of course read things and you can delete things. That sounds that like, okay, that might be a good analogy here. Why is that problematic? The first thing is that that seems easy in the first place, but especially if you like, let's say you started like creating a very flat but wide domain model, you might run into the question of what do I actually return when I want to go to customer/4711, right? Because if you just like take that entity from your database and throw it at Jackson, it will just like traverse all the relationships and then basically, oh, there's an order, oh, there's an address, and there's line items, and there's products, and then all of a sudden you have like a couple of megabytes of JSON representation in the web. And the fundamental problem even being, like as we said, there are different relationships between the things, and usually by definition you don't want the product name to be updatable when you actually put the customer resource, right? Just because it was arbitrarily pulled into the representation by some means. So I've seen a couple of projects where people were busy thinking about, oh, what is that URI supposed to look like, and what URI structures are we using, but never really spend a minute to think about, okay, what do we actually include in our representations, and what do we not include into our representations, you usually get into those discussions quite quickly. Yeah, again, just to restart on the value objects thing. If you introduce those value objects, you usually have to teach your serializers, which these days usually is Jackson, that these things are like value objects, so you have to basically unwrap them. That's a bit of a pain in the ass. Also, one reason why some people like try to avoid that, but that's, yeah, you have to do that effectively. With the aggregates, it's kind of there's a nice parallel here. And the thing is that we've already pointed out, right, that the aggregates are very important scope of consistency. So if I go ahead and align my resource design or my resource I've identified in my systems, and again, that makes it necessary that I actually even have thought about what my aggregates are in the system, then I basically get a nice balance, because that's the thing I can update and that's the thing I want to update, so that really maps nicely to that, let's say, requirement of like put operations, that they're like idempotent, and basically you get the resource, you get a certain set of data, and you can actually write that back. So you have parallels or symmetry basically between the operations. You can refer to things, or identifiability and referability is sort of two sides of the same coin basically, and HTTP has a nice concept for that, right? That's URIs effectively. So the aggregates become a really good candidate for an HTTP resource, right? So they basically, HTTP resources and aggregates share very important aspects of their traits. That's the thing I was looking for. They share very special traits. All right, so the thing is that REST for most, or for a lot of people, is basically URIs, which means resources, identifiable resources, a dedicated set of operations on those resources, and representations. That's one thing. Then there's this infamous HADIOS acronym coming in. It's not short for Hate Oracle Application Server. It's Hypermedia as the engine of application state. So that's a mouthful, right? So what's hypermedia in the first place? The idea that we not only serve the client's data, but also navigation information, which usually means links, named links usually. That's quite important, because you have to sort of identify and be able to find the links in the representation. And then that some people equate hypermedia with HADIOS, which is not really true, because HADIOS again then adds the bit of, okay, we conditionally add links in to represent state actually. So whenever an order is actually payable or expected to be paid, there's a certain link appearing in the representation, right? If the order is paid, that certain link is not appearing anymore, right? So gonna get back to that in a second. So why do we actually do that, or what's the thing here? I mean, there's one thing is that if you avoid thinking about hypermedia, then you lose quite an important means to actually structure your representations. As I said, like if you have these like different kinds of relationships between aggregates, and that in turn meaning resources, then you need some means to say, okay, the order was placed by a customer, but I'm not going to like pull in all the customer data in the first place, but only point to the customer, right? I give you a reference to the customer, and without addressability, without URIs, and without links, and that meaning hypermedia in the representation, that doesn't really work at all. So you sort of need this this aspect of REST in your APIs to be able to like govern more complex resource structures basically. So the thing is that, I mean, that's like connecting resources to other resources, right? That's Hypermedia. That's still not HEDIOS really. Let's say we want to go ahead and express that we expect an order to be paid, or an HTTP call to be made to pay the order. We could just go ahead and like document that somewhere, right? So we have the state of our order, that it's expected to be paid, and we just like document, okay, to pay the order you have to issue an HTTP call to that URL, and then you have to send that JSON and be done with it, right? So the thing is that knowledge, we have to sort of bake that into our client, and we have to document when that is actually allowed. Let's say, okay, how does the client identify the state payment expected, right? And we could like bake this knowledge into the client by saying, okay, there will be a field that will have a certain value, and if that value is X, then you are supposed to do that. So we bake a lot of domain knowledge into the client, right? And we can like slightly alter that or change that by teaching the client more protocol information, or more protocol knowledge, basically. What does that actually mean? So if you have a non-hypermedia based system, so basically let's say a client and a server arrangement where they both don't use hypermedia elements, they don't use links, right? Then for the example I gave you, you have to put a lot of domain knowledge into the client, right? The client has to know that there will be a certain field of a certain value in which situation it's allowed to do X, right? So it has to do that. So if we change that, so if we so there's like the amount of protocol knowledge is very, very limited. So it basically only knows about, okay, there's HTTP and there's JSON, and that's the only protocol knowledge it actually has to have. The other stuff is already up here, right? That means those clients will react very allergic to changes in that domain knowledge, right? If the server decides to change, oh, you can cancel the order, like let's say we allow a different state where you can cancel the order. I come back to that in a second. Then we have to update the client, right? So it's like tightly coupled. If you move like more to the right side of the spectrum, if you teach it more protocol knowledge, you are able to reduce the amount of domain knowledge in the client, and by that reduce the coupling. Why is that so important? Because especially in a like these days, like everyone's talking about microservices, or let's rephrase that to system of systems, right? If we have a lot of systems that interact with each other, when does it, I mean, what's the primary driver for such an architecture? You want to be able to redeploy one of the systems without having to redeploy the others, right? You want to roll out features quickly. So if you're very likely to break the API with a change, that means you lose that trade, because then you have to redeploy other systems as well, and then other systems as well. So you basically get to a distributed monolith, because like for that change in that one system, you have to redeploy 5 others. And if you're on this side of the spectrum, you're likely to break the API because the coupling is much higher, right? So you want to move to that side, because then you can change the API of the system without lines. That's the thing here. Let's get to a example here. Assume, and actually I have this in running code. I think I get to that in a second. But assume this thing to be an excerpt of the order, right, that we've placed. We're not in the e-commerce scenario here anymore. It's this example is using a Starbucks-like coffee ordering experience, basically implemented as a REST service. So let's say we have this order, and the client knows while the order is in the status payment cancel the order by issuing a delete request to some URI, right? So it's basically looking at this piece of JSON, and then we'll have some code implemented that says, if JSON field status equals payment expected, I issue my HTTP call, or I display the button to issue the delete request. That's basically it, right? So along comes a new requirement. What does that mean? Because if that thing is hard-coded, that expected value is hard-coded into the client, that will basically break now, right? So if that's what's payment expected in Danish, I know you probably know, or in German, 2-bit Zahlen or something, right? If this thing changes here, if this thing no matter whether it's actually semantically important, because it might have just been introduced for displaying purposes in the first place, but as the client now has like coupled the decision on whether to display the cancel button onto this very thing here, it will break even for those like apparently simple changes, right? So the idea is to rather, and that's what I mean with introduce more protocol knowledge instead of domain knowledge, is to actually look at the links that are available in the representation. That requires the server to actually serve those links in those scenarios, right? So whenever you can cancel an order, I will add the cancel link to the representation. And then the client adhering to that concept and saying, I'm not looking at any of this, really. I might be looking at this for displaying purposes, but I'm not looking at this stuff for like those business decisions, right? I'm just looking at, is the cancel link there? And then I actually display the cancel button, right? So that allows us, or the server, to mess with that field whenever it wants, right? So it might even allow us to, I have this thing later, but when the order is paid, it's in that state here, and the original requirement was that I can only cancel the thing if it's in the status payment expected. What if the business decides that those orders can be canceled at other stages of the order, right? Even if when it was prepared already. If the client was still to be looking at this field, that would just like completely break. With that approach, you could just like even introduce that cancel link popping up at a later point in time, and the client would just like transparently pick up that new feature, right? All right. So what we're trying to do here is we're basically we're dumbing down the client and making the client more intelligent at the same time. Dumbing down in terms of we try to reduce every decision the client makes to the decision or to whether a link is present or not. Think about security or permissions. Can I actually execute or is the client actually allowed to cancel the order? Like if the client was ignoring the links completely, how would the client even determine whether it was allowed to cancel the order? It had to do like a separate request, ask for permissions, check the user account. The user account permissions have to go to the client. If it just like follows that is the link present or not, the server can decide whether that client is allowed to do that and then render the link or not, right? That's basically it. Right. So that's because you with that approach, because you get a lot of control over what's allowed at what point in time on the server. It's usually a good idea if you like instead of like issuing patch requests to change resources to actually introduce like dedicated state transitions. So that's sort of the analogy between like calling setters on every property of your domain object instead of using a dedicated method for a changing operation instead of calling the individual setters here. I mean that's the payment thing or canceling a an order could have naively been implemented by just like issuing a patch request saying status cancelled or something, right? That's what it would look like if you treated your REST API as a CRUD service, right? You load the data, you manipulate the data, and then you write the data back. And that's basically moving quite a few business logic to the client. I tweeted that recently. It's quite ironic because the more generic that API becomes, the more logic you pull to the server, which is something you actually to the client. Sorry. Yeah. 4 minutes. Okay. That's another thing. Just want to briefly run over it. Usually, if you have like, especially your Java-based domain model, you have a couple of back-end concepts that sneak into the code that you shouldn't, or actually, it's quite dangerous if you expose them one-to-one through your clients. One thing is that database identifiers usually should be stripped from the representation because there's an HTTP concept for that, right? You identify things via resources. What's the server supposed to do if you have, let's say, a URI customer 4711 and the ID in the representation you send to put the customer is like 4712, right? It's just like doesn't really make any sense, right? Because the server has to resolve the ambiguity. Just remove those things. Optimistic locking information like add version attributes should be translated to E tags, really, so that the client can actually do things like, okay, please server, give me the customer, but only if it doesn't have that E tag anymore, right? In other words, if it has changed in the meantime. The same goes for the last modified header. The same can also be used for put requests. Only update the customer in case it still has that E tag, right? It's basically a version here. The thing I mentioned explicitly, those here explicitly, is that if you throw Spring Data REST at your domain model, it will actually do exactly these things, right? So it will translate the backend things or the aspects of your domain model that are actually backend specific into the HTTP appropriate ones. But I might be able to get to that in the other talk then. Okay, here's just a final pointer to the example I have on GitHub. It's called RESTBugs. It comes from the RESTful Web Services book from O'Reilly, Ian Weber, Jim Weber, Ian Robinson, my gosh, and Savas Parastadidis. I probably butchered this name again. Great book. It basically has this coffee ordering experience in as an example in there. It's kind of cool because it's very tiny but has a lot of interesting things there, things that you usually encounter when you're building more complex REST APIs, like conditional state transitions, waiting for the server to finish a long-running task here in that step. The book implements that stuff with JAX-RS and basically JAX-RS and a lot of handwritten code. And I've built a Spring Boot REST, data REST based version on it. So if you want to see something like this, like in real code and working, check out Spring RESTBugs. I have the link in the slides here. Just that thing here that like when you naively want to implement the state diagram I had before, you usually throw Swagger at stuff and you end up with like resources baked into the client. That's quick but wrong. You could instead go ahead and just like introduce link relations. So basically say whenever there's an orders link in the representation, you can either post to it to create a new order, or you can get a list of orders, right? So the point here being you don't want to create incentives for the client to bake information into it that you might that Hypermedia was actually the more proper means to communicate that stuff. Yeah, that's just the implementation side of things. I've implemented most of it is taken care of by like Spring Data implementations, but the payment, the point here being there will be some parts to your API that work in a rather cruddy way, right? Placing the order and let's say updating the order, yada, yada, yada. For those, Spring Data REST is a fine piece of technology. I think you can just like let it do its thing. For everything that's like more driving your business, how do you actually pay those orders, and how do you actually move the order through those different states. There's a bit of manual code, and I'm not sure the projector really transfers it. Here's like a shade of blue in here. So there's means to customize Spring Data or hook functionality into it so that it just becomes like a part of your API naturally, and the client doesn't really know whether that stuff was implemented manually or via Spring Data REST. Okay, that's a couple of things regarding the implementation, but I skipped those for now. Right, you want to find the example in my GitHub account, Spring REST box, if you just Google for that. I've also like written a blog post on that part of the talk I had on why I think moving to a more hypermedia-driven API world is of benefit to the systems. And that leaves me with exactly no minutes for questions. One maybe. One question? Question. Okay. The question is, how do you handle versioning? And I actually also have a tweet for that. It's like the first question, or the first statement I usually get is, I don't need Hypermedia because my REST API is not that complicated. And the second question is usually, how do I do versioning on it? And that's usually the point where I have to answer, okay, if you were to be using Hypermedia, you're less likely to get into the problematic of versioning, right? I've probably seen in the slides in the talk that there are a couple of aspects that become pretty easy to evolve when you're using Hypermedia elements. The other aspect is that you usually don't do yourself a favor if you even in the first place think of a version of an API, because what you're actually doing, no matter what versioning strategy you use, like HTTP headers, URL segments, or whatnot, you're basically dealing with a new API. You deal with new resources. You probably lose like cache hits and whatnot. So you better think of like something new as a separate API, right? A new API. If you start doing that, then things become just like, okay, I just change things, and then that's just it.
I think we have to stop here, Oliver.
Okay, sorry for overrunning. I'll be around like till tomorrow. Thank you.